0.
Alright, so welcome to another video show. This is your tutor CK Science Zambia. We now look at question 8, which is extracted from 2001 for the sake of revision. A circuit consisting of two resistors, R1 and R2, carries a current of 2.0 amps, is shown below. So this is the current. So this current which is here, it is the sum of the current flowing in R1 and R2. This is due to the fact that resistor 1 and resistor 2 are connected in parallel. So in parallel connection, resistors receives different amount of current. For us to find the total current flowing in the circuit, we have to sum the current flowing in resistor 1 and the current flowing in resistor 2. The voltage provided by the cells is the same flowing in resistor 1 and the resistor 2. Then this I2, which is here, 0.5, is the current flowing in R2 only. Then the instrument here, the ammeter instrument, it is measuring the current flowing in resistor 1 only. So let's now go to the question. The first question reads, find the value of resistance in R2. We want to find resistance in R2. So to answer question 2, we want to find the resistance in R2, which we don't know, and we know the current flowing, which is 0.5 amps, and the voltage in R2, flowing in R2 is 6.0. So the voltage there is 6.0 volts. So using Ohm's law equation, we can find the value of R2 by finding the value of V, which is 6.0 V, and the value of the current, which is 0.5 amps. Then R2 is equal to, if you do not have a calculator, like the way I am here, don't have a calculator, we can easily find the value here by simply looking at the place value of 0.5. So in this case, we have one decimal number, so we have to multiply by 10. Whatever we have done here, we should also do it on top there, which will now multiply 6.0 by 10, we get a 60, and 0.5 times 10, we get a 5. And now when you divide 5 into 60, we will probably get 12 ohms, and that is the answer. So the amount of resistance provided by R2 is 12 ohms. We now go to question B, which reads, what is the reading of the ammeter? We want to find the reading, meaning that we know the function of the ammeter. It is used to measure the current flowing. So in this case, this ammeter is measuring the current flowing in R1. Okay, and we want now to find the reading, which is the current flowing in R1. So remember this principle that in parallel connection, current differs, and the sum of current flowing in resistors connected in parallel is the current flowing in the circuit. So in this case, we know the total current flowing in R1 and R2. So the total current, which is equal to R1 plus R2, okay? And the total current is 0.2 amps. What is the value of R1? This is what we want to find. Sorry, this is current, not resistance, please. Okay, what is the value of R1 of I1? This is what we want to find, plus the value of I2. The value of I2 is 0.5. So we put 0.5 amps here. So we have to take this, we do the like terms together. We have to take this value here on the other side. So we have current 1 is equal to 2.0 amps minus, when you cross an equal sign, the positive changes to a negative, 0.5 amps, and our current flowing is 1.5 amps. I repeat, current flowing in parallel differs. Therefore, the sum total of current flowing in R1 and R2 is the sum total of current flowing in the circuit. And this is the expression that I've given here. Total current is equal to current flowing in resistor 1 plus current flowing in resistor 2. And the total current, which is 2.0 amps, and the current flowing in 1 is the one that we want to find, is the reading of the ammeter in this case. And we know the current flowing in R2, which is I2, is 0.5. Therefore, you do the